I'm going to present some research on racial disparities in the 1918 flu pandemic in US cities. And this research was done jointly. It's a 6-person team, and it was led by me and Martin Eierman, who has just graduated from sociology at Berkeley. So hopefully some of you know him because he's really great. So let me set the scene. The 1918 flu was really distinctive for at least 3 reasons, and 2 of these are very well known. It was a very deadly flu, and it also had this super weird age pattern where instead of the usual flu hits young people and old people in this U shape, it had this W shape where young adults were also very affected. They had very high mortality in the flu. But a third distinctive feature is not well known, which is that in US cities, there were strikingly small racial disparities relative to this backdrop of very extreme racial inequality at the time. That something weird was going on was actually well understood at the time, as this quote from a prominent Black minister makes clear. The Reverend Francis Grimke said, "During these terrible weeks while the epidemic raged, God has been trying in a very pronouncedly conspicuous and vigorous way to beat a little sense into the white man's head, has been trying to show him the folly of the empty conceit of his vaunted race superiority by dealing with him just as he dealt with the peoples of a darker hue." Okay, so people understood that racial disparities were smaller than usual and that this was weird. And this is analyzed in a small amount of research, which is over on the right side of the screen here, but it's actually been largely forgotten. And it is actually surprising. So for one thing, racial inequality at this time really was extreme. And so that, is one kind of cause for surprise, but it's also different from what's happened in the COVID pandemic, where racial inequality is also really extreme now, even before the pandemic, but the pandemic intensified that. It made racial disparities in mortality, adjusted for age, worse. And in 1918, that's not true. In fact, people in health research often kind of talk about pandemics and other kinds of crises and disasters as something that will intrinsically make disparities worse. So there's this kind of truism, like whatever is the existing inequality, then you layer on top of pandemics, the inequality is going to get worse. So one way you can understand what I'm going to show you is that it's a kind of instructive exception to that general rule. Okay, so in our paper, we start by just giving the first kind of most comprehensive description of racial disparities in flu deaths in US cities in 1918. And the short version is, yes, they were a lot smaller than usual. And also they were sort of uniformly small. So there was very little variation across cities, even relative to a normal year. And this is happening because in the flu, the flu raises non-white mortality by a factor of 3, but it raises white mortality in cities. This is all in cities by a factor of 5, right? So this is very extreme inequality. By the way, when I say non-white, I'm going to use non-white and Black sort of interchangeably because that's sort of accurate to who was in cities at the time. But the statistics we have are white versus colored, which is the racial classifications that were used in vital statistics in 1918. So we are drawing on 11 different data sets, but our workhorse is a set of vital statistics from 70 US cities that had race-specific, cause-specific data. And what we get from these vital statistics is a count of deaths. So we know how many people of each race died of flu or pneumonia in each city in that year. And to make death rates out of death counts, you need a denominator, which gets a little bit trickier. So I'll just say a little bit about it. So normally what I would want to do, I want a denominator for 1918. Okay, I've got a census in 1910 and a census in 1920. I'm just going to interpolate between them. There is a problem with that in this case, which is that the 1918 flu itself was such a huge population shock. It killed a ton of people. It led to people migrating out of cities. We do not want to read that backward into the population denominators because it would be distorting. And so what do we do instead? we ended up doing two different things that are very different from each other, just to see, do the different assumptions of these end up making a difference? Luckily not. So our main measure is going to be, we just interpolated denominators all the way up to 1930 from 1910. Now, if you know anything about this era, you'll be thinking to yourself, wait a minute, migration patterns were really different in the 1920s compared to the 19 teens. In the 1920s, you have a halt to a lot of international migration due to restrictive laws that were passed, but you also have an intensifying great migration of African Americans up from the South. Do I want to read those 1920s patterns back onto my 1918 denominators? No, I do not. And so that's why we check that that's not distorting things too much by making this like pretty wacky alternative, which is basically like, we're just gonna use the non-infectious death counts as a measure of how many people are living in a city. And we're gonna predict them forward from 1918 from the prior years and say, okay, that's gonna give us a pretty clear idea of roughly how big of a city is that. That's also not a great measure, but the nice thing is it's a really different, not great measure, and they end up agreeing super closely in the results that they give us. And so at that point, we decide we don't have to worry anymore about denominators. We've done our demographic due diligence. Okay, hopefully that's all that I think I'm going to say about measurements, and I will get to results. So the first thing I want to say is just descriptively, those small aggregate racial disparities in 1918 are relatively small, are really being driven by small disparities in those crucial young adult ages, the 20s and 30s, where mortality was so much higher than expected. So basically what's happening is the disparities are small because white young adult mortality in cities was really, really high. And so, one way we want to think about this research question is, if we can explain why white young adult mortality was so extremely high, that's going to explain what we're looking for. And so we end up looking at four candidate explanations, which we put into two categories. The first, and I'm going to try to dispense with three of those explanations quickly and focus on the one that performs the best, which luckily is also the one that uses formal demography in the analysis. But first we look at some city level factors, which are things like cities' adoption of non-pharmaceutical interventions. So the kinds of stuff that we've had lots of debates about today, things like mask mandates, school closures. And we're also going to look at city level segregation. And the main thing I want to say about these is that these hypotheses, they don't turn out to, in any of our models, explain any of the variation across cities in in the size of disparities. And because of that, we also don't think they're driving the variation over time. But it also wasn't crazy to hypothesize that they would account for these. So like thinking about the non-pharmaceutical interventions, they were definitely unique to 1918. Past research has shown that they did matter, like they were effective in reducing mortality. And also, like, while the public health responses that cities organized in the pandemic were typically quite racist. So for example, cities in both the North and the South organized whites only hospitals and clinics. But at the same time, by 1918, there's fairly robust networks of Black municipal reformers in cities who are able to push back against that. And so we also kind of thought that even if cities are really only responsive to white mortality, the things that they might organize could actually end up disproportionately helping African Americans in cities, because their mortality would otherwise be so much higher because of just the really appalling conditions that people were living in, just intense respiratory crowding in really dilapidated housing that was very, very conducive to spreading respiratory disease and not conducive to survival. Okay, as a tiny and fun digression, so when I said that non-pharmaceutical interventions have been shown by other research to work, actually what the research has shown is they did work, but not that much. And the reason they didn't work that much is that they were not sustained for long enough to be that effective. And the reason they were not sustained for long enough is that they came in for ferocious resistance. So for example, we found this in a Topeka newspaper article. Both the health commissioner and the health officer have been the target during the last few months for gobs of criticism and insubordination against what was termed the autocracy they were establishing in depriving the citizens of the privilege of freedom of action, the right to mingle with flu germs. To be fair, this was not the only reason that people hated this guy, Clark, the health officer. A few weeks earlier, he'd been resoundingly mocked in the same newspaper for saying, "How can you expect the common people to heed influenza warnings when our socially best people sometimes show just as little sense about such things?" Right, so this guy was basically an asshole. And the debates about non-pharmaceutical interventions were really politically polarized in a way that we might recognize today. Anyway, non-pharmaceutical interventions were not sustained long enough. They only sort of worked, but they did generally reduce mortality. They have no effect on racial disparities. And we find that segregation also is not associated with disparities. So we end up turning to a different kind of explanation, which we're calling social immunology. And the idea here is we want to think about the social histories of the urban white and non-white populations in 1918 United States. The white population is spread all over the country. It has a lot of people who were born in the United States, but it also has many, many European immigrants. And it's a population that tends to be concentrated in the Northeast and the Midwest. The non-white population is disproportionately Southern. It's disproportionately Black internal migrants. So these are people who were born into rural agricultural settings that were deeply impoverished. They then migrate first to Southern cities and then eventually to Northern cities as well. And once in cities, they were made by law and by violent force to live in like truly appalling conditions, just intensely crowded and dilapidated. And so again, this is a population with rural origins, but then migrating and living in cities in the worst conditions that cities have to offer. That is a very particular life course history of exposure. And so we want to think about that as how does that play into what happens in 1918? And we argue that these distinctive social exposure histories offer the possibility of explaining the small disparities, relatively small disparities in 1918 through the interaction of the social history of these two racial groups with the natural history of this virus. So what do I mean by that? This is a complicated table. I'm sorry, forget it. The basic story is actually simple. Either non-white people were more likely to have had an earlier flu exposure that was protective in 1918, like it gave them some immunity, or they were less likely to have had an earlier exposure that was harmful. And the details trade on these two really distinctive biological features of the 1918 virus. One is that it had this really mild spring version or somewhat mild spring version before it evolved over the summer to become a much, much deadlier virus in the fall of 1918. And the fall is when almost all of the deaths happened. And so one possibility, and this is actually the only idea that's in the sort of pre-existing literature on racial disparities in this flu, is that non-white populations had more exposure in the spring because they always had more flu exposure because their conditions were so poor. And then that actually ended up being protective in the fall. So this was put forward by the historian Alfred Crosby. He didn't have any evidence for it. It's just a speculation, but I think it's a good speculation. And so we test it. And the short version is, I'm going to skip over the details because it's a short talk, but ask me as much as you want about it. We do find that it did not seem to matter. So we don't think it's actually spring exposure, most likely. So we focus on the other social immunology hypothesis, which is the idea that white populations might have been more likely to have had this harmful earlier exposure through a mechanism called immunological imprinting. And so the idea here is that the 1918 flu had some combinations of similarities and differences with an earlier flu that circulated around 1890, with the result that if your first flu exposure was to that 1890 flu, your immune system would have reacted in 1918 in a very particular way. So let me give a little more detail about this hypothesis. So it's basically like, if in 1890, if you were a child and the first flu that you were ever exposed to was this 1890 virus, and you got it in 1890 or 1891 or 1892, your body would have learned this is the kind of flu that we react to, and been primed for it. The 1890 virus was very, very different from the 1918 virus. And so the idea is that if you were primed to respond to 1890, when you recognize a flu, your immune system responds in all these counterproductive ways. It's going to flood you with antibodies that can't actually do anything. That produces a lot of inflammation. You might die of that. Meanwhile, it's crowding out a more effective immune response. So that's what you should be imagining. And this hypothesis has been developed by Michael Warabai and Alan Gagnon, who are respectively an evolutionary biologist and a demographer working separately. It's been developed by the two of them as a way to potentially explain that really high young adult mortality in 1918. We want to add the idea that perhaps it could also explain the small racial disparities. So the idea is that if urban non-white populations, because they did not tend to grow up in cities, maybe they were less likely to have been exposed to the flu in childhood when they were in these rural areas, and as a result, less likely to have had this imprinting mechanism. And could that account for why it was the urban white population that had this really aggressive mortality response, even compared to the urban non-white population of the same ages? So that's the idea. We do not have any great way to test this. So keep your expectations in check. But what we did try to do is just think hard about, okay, if this were right, what would it imply across different domains where we might be able to have some kind of test, even if it's pretty sketchy or suggestive? And we came up with 5 such tests across different domains. So these are 5 things that we think have to be true if this imprinting mechanism is going to explain the small racial disparities in 1918. So the small disparities have to be driven by the correct cohorts to have had this imprinting happen. It has to be true that among people who are in cities in 1918, the non-white people were less likely to have been imprinted. It has to be the case that if a city had more imprinted people, it would have had worse outcomes in 1918. Imprinting also has to be sufficiently prevalent and sufficiently harmful that it could actually account for this huge effect on mortality. So those are the 5 things that we think have to be true. And in order to test them, the first 3 we can look at a little bit empirically. The last 2 are where formal demography comes in. It's all just modeling. Okay, so were racial disparities driven by the correct cohorts to have had this imprinting effect? Yes, they were. So remember, they're driven by these 20s and 30s ages. Those are actually exactly the right cohorts. So we're good on that score. These 2 cohorts, the 20s and 30s, those account for about 3/4 of the decline in disparities in the aggregate. So that's why we say, yes, that part is right. This second and third one that are about who had first flu exposure and then how does that relate to what happens in 1918, we don't have any measure of first flu exposure. So we just use urban residents earlier in life as a proxy. And we don't even have a measure of urban residents in 1890 because that census is lost. It was destroyed in a fire. And so we basically just link people in the census between 1910 back to 1900 and use that to get a really rough idea of which cities were migration destinations and was it more white or non-white people who were these urban migrants. And basically, we confirm that it is true that urban white populations were more likely to have grown up in cities. And it's also true that even with our super noisy and imperfect measure of urban origins, it actually is true that cities that had more people who grew up in cities did worse in 1918 in terms of survival. So, this is a sketchy test, but we can't, we can't knock down this hypothesis from these tests. Okay, so this concludes our empirical tests. And now finally we come to the part where there's actually some formal demography, which is we want to know what can we say about first flu exposure, even though we have no measure of it. Sorry for all my tech challenges. Basically, what we're trying to do is use models to think about what are the parameters that you would need in order to get imprinting effects that are big enough to explain those small disparities at the 20s and 30s ages. And are those underlying parameters even remotely plausible? And so first, there's two stages of the simulations that we do here. So the first question we're trying to answer is, could that huge jump in young adult mortality for whites compared with the surrounding ages, could that plausibly be driven by immunological imprinting? Or is it too big of a jump for that to be reasonable? And so what we observe is cohort aggregate mortality. And so the model that we have is we're imagining that those aggregate cohorts are a mixture of imprinted and non-imprinted people. And we're assuming that the people who were not imprinted had mortality that was more in line with the surrounding ages, but without this particular young adult effect. And then it's only among the imprinted people that you'd have this big young adult jump. And that means there's this trade-off between how many people need to be imprinted and how high the imprinted people's mortality needs to be in order to get this big aggregate jump, right? So the more people that are imprinted, the less extreme the imprinting effect has to be in individuals. And so that's what we model. And basically what we find is that, this is just algebra essentially, but what we find is that in order to explain those young adult jumps in the white population, the mortality of imprinted people has to be really, really, really high, like 20-year-olds having more of a higher mortality risk than 70-year-olds, unless imprinting was close to ubiquitous in the white population. So if this imprinting mechanism is going to fully account for this big young adult mortality jump in the white population, it has to be like most of that white population, like 80 or 85% of that white urban population had this imprinting effect or was imprinted by the 1890 flu. That's pretty extreme, right? So we get here and we think that's probably not plausible. But in order to actually know if that's plausible, this is where we do our second stage of simulations, where we try to back out, well, what would the historical flu transmission rates have needed to be in order to get such high imprinting rates, right? So if you want to get to 80 or 85% of the urban white people of these cohorts having been imprinted, what do the flu transmission rates have to be like? And so the way we do this is we make a giant multi-state life table that has cohorts aging through exposure to different flus before 1890, and then in the pandemic years, 1890, 91, 92. And so in order to be imprinted, we say, first, you had to not be exposed to any flu before the 1890 pandemic, and then you had to be exposed into the 1890 flu. So it's this joint exposure where first you were not exposed and then you were. And that's what we can get from the multi-state life table and ask, well, what combinations of transmission rates are compatible with getting to, say, 80% of the cohort imprinted? And surprisingly to me, in the end, they're actually not crazy. They are in line with historical pandemic flu and seasonal flu attack rates that comes from virological research. And the other thing I'll say about this graph, which is confusing because it's talking about this refocusing rate, what is this? So what's happening in this graph is the x-axis is showing you the pre-1890 transmission rate that you would have to get, and the y-axis is showing you the in-pandemic transmission rate. And then where there are dots, that's showing you, yes, there is a multi-state life table that can produce cohort imprinting rates of around 80% or more, that has this combination of parameters. And the different colors have to do with this idea called immunological refocusing. And this is a modification of the imprinting hypothesis that comes from the demographer Alan Gagnon, who's kind of speculated that, it seems like you don't necessarily have to only be imprinted by your first flu, but sometimes if you have had some prior flu exposure, but then you're exposed to a really deadly flu in your childhood still, that could refocus your immune system. So you get imprinted like it was your first flu, even though it wasn't. So we also have variants of the model that have this refocusing effect happening at, with different likelihoods. But the black dots are, even when we don't allow that to happen, which imposes a lot more restrictions, right? Where seasonal flu had to be less common, because in order for imprinting to happen, you have to have never been exposed to a flu until 1890. Even in that variant, we get surprisingly realistic flu transmission parameters in our possibility space. Okay, so what do we take from all this? In the end, we made these 5 attempts to knock down this imprinting hypothesis. None of them succeeded. So the hypothesis is still standing. I would not say we really gave you evidence for it. I would say that we made a bunch of attempts to give evidence against it and repeatedly failed. And so this is kind of our best explanation left standing at the end of this analysis. And stepping back from these details, this analysis is interesting to me, partly because it offers the possibility of a consilience between these 3 really distinctive facts about 1918. So if it's really about these early childhood exposures back in the 1890 pandemic, then we potentially have a way to explain some of the virulence, the super weird age pattern, and the surprisingly small racial disparities all together as a package, which is cool. But where I want to end is actually with the framework that this gives us, which is that what happens in the pandemic reflects what was happening before the pandemic, but it does so mediated by the pandemic specific biology. So there's a lot of reasons to care about history, in my opinion, but one that people often find compelling is that it should tell us something about the present or the future. But to me, the social immunology hypotheses that we end up finding to be the most compelling are basically saying that this arresting fact about this global pandemic is basically just a big historical coincidence. It's the coincidence of how migration patterns intersected with a shift in which viruses were circulating over a 30-year span. That's pretty contingent. And so to me, this is actually really a cautionary tale about reading 1918 forward and assuming that there is some universal path of pandemics that we're now reliving today, or assuming that pandemics interact with social inequality and reproduce inequality in the same ways. And for that matter, it's even a cautionary tale against the idea that racial group boundaries have exactly the same meanings today that they did a century ago, when they were really a proxy for these very distinctive exposure histories. To me, the social immunology framework suggests that drawing historical analogies, like from today back to 1918, requires that we be very careful and attentive to the details to understand how particular social histories of populations intersect with particular natural histories of microbes. So that, we think, is the biggest lesson, and I will stop talking.